We are here today to talk about enabling a rapid deployment of OSIsoft Pi. My name is Herbert Falk and I'm a Senior Solutions Architect for SISCO. Customers receive an immediate value by installing and commissioning a Pi system, as it provides visibility to real-time business data and allows customers to begin analyzing that data. However, in order to turn that data into information and provide more value, customers need to embrace the deployment of Pi AF. There are many perceived barriers to the deployment of AF that lead an inordinate amount of customers to not install and embrace AF and therefore not unlock the full value of the Pi system. This presentation discusses those barriers, how to break down those barriers, and methodology and tooling that will allow a rapid deployment and potential adoption of AF and the advanced capabilities of the Pi system. What are the deployment barriers? Many companies believe that Pi tag naming conventions is good enough, or the company has various objectives for Pi tag names. There are customer silos, each with different methodologies and objectives. There's lack of communication between those silos. Lack of expertise on how to solve the silo problem or how to develop the context for Pi AF. There are perceived challenges with maintaining AF. And there's a difficulty in designing or capturing the contextual model requirements to be placed into AF. Meaning, what does a company want to do with AF? This sometimes creates analysis paralysis, and some companies actually believe AF configuration and maintenance is difficult. So how do we break the deployment barriers? Think big. Address enterprise-level requirements. Use the Pi system as the focus of information integration. Use available standards as a starting point. Educate and communicate between the silos and business stakeholders to increase awareness and buy-in. That is a continuous effort that needs to be ongoing. Start small. Choose a project that provides immediate results. Leverage any existing information sources so that manual entry is avoided. Implement in a manner that provides for future scalability so other business requirements can be addressed. Scale fast. Get more champions. Show them what's been accomplished in a short period of time. Keep the momentum moving by addressing other business requirements in a rapid fashion. Use recognized design patterns to build a strong foundation. The current methodologies that most corporations or businesses use today is they do their contextual design. They design it from scratch. They typically use manual entry or for definitions of elements and relationships. This can be very time-consuming between the design process and the actual entry of the schema and the elements. The time that it takes is really dependent upon the complexity of the business requirement that's trying to be achieved, but it can be weeks, months, or more. The other problem with manual entry is it's prone to human error, and typically revision and maintenance is not addressed in a design from scratch methodology, and therefore the contextual information that's placed into AF is difficult to revise. The SISCO methodology attempts to use standards as a starting point. We have methodologies in place that allow standards to be extended if it's needed. We know how to use and leverage existing sources of information. We have automated processes in place in our methodology to save time, alleviate errors, and it allows for maintenance and revision. Additionally, with the tooling we've chosen to implement our methodology, the tooling can generate documentation, and you can maintain that documentation, the schema, all in electronic format in a tool. Starting with a blank canvas, you have no points and no context. For quick results, as an example, we can import a substation from an energy management system model and create over 2,000 tags, over 4,500 elements, and 7,300 relationships. Creating the elements is not the difficult part. It is creating the relationships, which is the time-consuming part. But it is that part that allows you to address other unanticipated applications that may not have been able to be addressed in a straight parent-child hierarchy. The details of what was accomplished are shown on the display. It's created an extensible infrastructure in AF, which is immediately grouped and provides a basis and a foundation for condition-based maintenance, topological and power flow analysis, unanticipated applications, and it allows extension of the schemas to embrace other information in the future. It was done with no manual entry and no errors. It is an accurate reflection of the EMS model. So, how do you do this? You start by building a foundation within AF. We use CIM, the Common Information Model, file formats to convey information into AF. This allows us to convert information from existing sources into a standard format for import into AF. Once you deal with CIM in the electrical environment, there is another standard, IEC 61850, that is becoming more and more prevalent in substations and in industrial complexes. Obviously, if the information exists in 61850, we want to be able to translate it into CIM and bring that information into AF. Going even further, 61850 engineering processes can enable for automatic PI tag creation and PI interface configuration. And 61850 devices typically have the ability to capture high fidelity information for transient disturbance events that may be of very, very high use for determining if an asset has been impacted by, let's say, a lightning strike. The foundation in the electrical world is typically from an energy management system where the model is well known and well validated. The EMS can export a standardized set of files in what is known as CIM format. SISCO has a CIM adapter for PI-AF that can import that information and manage the AF elements and relationships, and using the power of the PI system actually allow for PI tag creation and management as well. The role of the SISCO CIM adapter is to support and manage multiple AF databases. It creates the element templates and other library information through a standard file format called RDFS. It creates instances, AF elements, through importing CIMXML. There's an additional CIMXML format that provides incremental changes. It provides the ability to update the AF model without having to replace the AF model in its entirety each time a change occurs in the model within the EMS. 61850 to CIM Transformation is a natural extension to the foundational process. Substation engineering and the single line diagrams that are created as part of substation engineering have much higher fidelity and detail than is in the normal energy management system model. There's been a lot of effort internationally to standardize how to use 61850 to master the EMS models so it can provide a single point of entry. The knowledge from substation engineering is imparted into a substation configuration description file, which is a standardized IEC file, through the use of what's called a substation configuration tool. The SCL file can be imported by a SISCO solution, which we know as the SCL to CIM adapter. The substation configuration description file is imported and a CIM file is exported, and then the CIM adapter can be used to import this into PyAF, but additionally the file that is produced on output can be used to configure the energy management system. It can potentially be used to exchange information with other systems such as SAP. We had a customer that wanted to go further. They spend hundreds of thousands of dollars maintaining libraries and spreadsheets and coordinating changes to those spreadsheets, creating Pi tags. They approached SISCO and said, we want a standardized naming convention based upon 61850. We want to do away with all these spreadsheets. We want to do away with all these complicated and non-coordinated business processes. The solution we provided builds upon IEC 61850 engineering processes, creating a file, a set of templates that define DNP index to 61850 naming convention bindings. These IED configuration description files, IECDs, can then be imported into a substation engineering tool. A single line diagram can be created. It can bind the measurements to topological elements in the single line diagram. And it can bind communication information to the instantiated IEDs. We can then take the SCL file, convert it to CIM. We can take the measurement information and create the Pi tags with the appropriate interface and acquisition parameters and instrument tags. We can also now use the information in this file to actually create the Pi DNP interface XML configuration file. Therefore, it can be deployed to a particular Pi interface node with no mistakes. According to our customer, this can save up to $100,000 per substation. When you're dealing with a 61850 device, there's a high probability that it has transient disturbance capture capability known as COMTRADE in it. COMTRADE is a standard format for providing transient disturbance information. It's very high fidelity. It's 8,000 to 20,000 samples per second. Each file or disturbance typically contains 8 to 20 channels, think tags, of disturbance information. In a mid-sized substation, there's typically 20 to 30 devices. SISCO has a product that can retrieve this information, auto-create PI tags in the PI system, and produce the following in PI Coresight. This is an event frame that was generated by a customer by importing a transient disturbance file, and you can see the high fidelity information. Please note that the total time span of this event frame is less than 1.2 seconds. One of the unique features of the COMTRADE utility is its ability to create one true view. What you see in front of you is a SCADA point, which is being acquired every 2 to 5 seconds, and then a transient disturbance occurs, and the COMTRADE utility reintegrates that information with the appropriate PI tag, thereby providing the one true view, including high fidelity information. Additionally, it's important moving forward to understand that businesses may not care what device generated the transient disturbance file, but rather what assets may have been impacted by that transient disturbance. And the COMTRADE utility provides the capability to provide that linkage. The COMTRADE utility uses the asset framework, notifications, PI tags, and event frames, and therefore utilizes a large part of the PI system. Standards provide a quick start and high value. Using existing tools, products, and solutions further can accelerate your deployment. It can be blended to address other applications such as microgrids. The model-driven architecture can allow extension for non-electrical models or custom-developed models. SISCO is actively working with OSIsoft to provide a solution for microgrids. The basis of the technology revolves around CIM, the use of IEC 61850, synchrophasers, and OSIsoft developed control algorithms. As part of this solution, the CIM adapter is a centerpiece. The microgrid solution is a good demonstration of how you can actually extend a previously existing standard. We use 61850 model extensions to create standardized PI tag names. We've extended CIM based upon the CIM and 61850 harmonization work to be able to detail intelligent electronic devices, PMUs, intelligent streetlights, charging stations, and more. At a deployment at the Illinois Institute of Technology, it became quite obvious that there needed to be a solution for easy and graphical development of the microgrid topological models. In response to that, SISCO's developed a solution that we call the CIMatic Designer. This is the process that the CIMatic Designer participates in as part of a potential microgrid solution. We use Enterprise Architect to actually extend the model. We choose the appropriate profiles or create them, which is a subset of the model. That information is used to create the element templates within AF and to populate the stencils within Visio with semantic information. The CIMatic Designer can be used to then edit the model and produce a CIM XML file that can then be imported by the CIM adapter and create the AF elements and relationships. Or if there's an energy management system that can export the microgrid information, the CIM adapter can be used directly from that model, with that model, and still manage AF. The look and feel of the CIMatic Designer is a Visio add-in. The schema from the model is actually maintained in the Visio stencils. What you're seeing on your screen is the resulting diagram for part of the IIT microgrid, and it's the instances and relationships that end up in AF. But Visio offers another capability. It offers a potential for a single point of entry. With the CIMatic Designer, we can create the AF infrastructure, the context for Pi applications. But with Visio, there's an opportunity to actually create the visualizations as well. As part of that effort to create a single point of entry, Cisco's developed a Cisco SVG converter capability that can take a Visio-generated SVG file and convert it into Pi Process Book or Pi Coresight SVG. This converter technology not only works with Visio, but can be used and customized to do other detailed transformations between application displays and Process Book and Coresight. As an example, we're going to show a mechanical creation of a model. If you look, we're going to look at what contextual information is provided by the templates right within Visio. There is no real model context being provided there. We can go and use the CIMatic Designer to import a profile, which further adds to the contextual information that is in the stencils. And you'll see that the shape data has been enhanced. This is typically something you would do with an ISA 88 or 95 model. You can then take this information and start instantiating. So we've created a vessel 1, we're going to create a vessel 2, and then using the typical Visio connector, we're going to say vessel 1 is connected to vessel 2. And then we come back to the CIMatic Designer and we say export a full CIM XML file of this model. At that point, we could load it directly into Pi, but we're going to bypass that step and just show you that an actual CIM XML file was created, and there's the information that was filled in for vessel 1. Further, you can go back and open up the shape data for the vessel and compare the two. All the instance information is maintained in Visio, so there's just one file that's used for revision control and maintenance. To make this all work, Cisco leverages IEC methodologies within our solutions and products. What you see before you is the typical top-down methodology used by most IEC processes. You get with business stakeholders to capture the business and use case requirements, and that's called a conceptual model. You take these requirements to architects, modelers, and domain expertise, and they start designing an enterprise-level information model, architecture, and defining system interactions. Given that information, the actual designers of information exchange define the methodologies to actually exchange the information and any mappings that are required to the existing system. The developers take all of the previously developed information and develop canonical methodologies to represent the exchange, like RDFX, XSD, DDL, etc. And then, based upon the currently existing systems and applications or future applications, those exchange methodologies can actually be used to exchange information regarding instances. In summary, the combination of the PI system and SISCO tooling and expertise can provide rapid deployment of contextual models with minimal manual intervention. This increases the business value of the PI system to the end customer. The methodology and tooling provides a repeatable process that allows rapid revisions and minimal mistakes and breaks the analysis paralysis syndrome. Enterprise Architect is a well-proven, low-cost tool that provides electronic documentation and report generation, and it is the tool of choice for modeling by the International Electrotechnical Commission. The methodology and the tooling and the solutions can be leveraged for non-electrical applications, custom applications, ISA 8895, and others. I'd like to thank you for the time that you've spent with me, and if you have further questions, please feel free to contact SISCO.